Hi everyone. It's been a while since we saw anything from our quadratics chapter, so I want to do a little bit of a recap today. Go through, see if you remember any of the stuff just to get your brain thinking, and then we can move on into the rest of chapter 3. There's only a couple sections left for us to do. So what I really want to look at is kind of what a parabola is, the different forms of parabolas that we have, and then why each one of them is important. So a couple things you have to remember. Quadratic functions are always second degree polynomials. That means that the exponent, that the highest exponent that you will have in your equation is an exponent 2. Whenever you graph a quadratic, you will get a parabola. This is what a parabola looks like. Okay. And then we can represent all of our quadratics. We can write them as a table of values. We can write them as an equation, or we can graph them. So you can have 3 different ways to display your quadratics or your parabolas. Looking at the screen, a couple important pieces to a parabola. A vertex, first of all, you should notice, it goes down and goes back up, or they can be flipped upside down, so it could be the reflection of what you've got here. The main kind of point that we look at for a parabola is called the vertex. That is your lowest or highest point, because remember, if it's flipped, it would be the high point. And that's called your vertex. And your vertex would be an ordered pair, your x and your y. The highest or lowest value is called your optimal value. So the vertex is both the x and the y coordinates, but your optimal value or your maximum or minimum, we're just looking at the value itself. So here we would just be looking at the y value of your vertex. A parabola hopefully will cross your x-axis. It could cross it 2 times, here and here. Last time we were together, we talked about it touching the x-axis only once, and it is possible if it's higher, it could actually not cross it at all. There is a potential for a y-intercept. Actually, they should all have a y-intercept, so your parabolas will usually cross the y-intercept somewhere. And then there's this imaginary line that cuts right through the vertex, cuts your parabola in half. It's kind of like a mirror. We call that your axis of symmetry. Okay, so we've got our vertex, we have our 2 x-intercepts here and here, we've got a y-intercept, and the imaginary line that cuts it would be your axis of symmetry. We can write our parabolas or our quadratics in 3 different ways. We can write it in standard form, okay, ax squared plus bx plus c. A, b, and c can be any number. A just can't be 0. We can write it in factored form. I know I said the bad F word, factored. We can factor this and write it in brackets. This was the form we had kind of looked at a little bit, and we should remember that these factors, when we break it up, these are actually your x-intercepts or your solutions to your quadratic. And then the third form, we haven't dealt too much with it other than just graphing it. This is called your vertex form, and we like your vertex form because the h and the k value are your vertex. So down below, I've got your 3 different forms. Okay, we've got our standard form, our vertex form, and our factored form, and all the information that you can get from them. So standard form is written this way. The a value, if it is a positive number, if it's positive, your quadratic opens up. If it's a negative number, it would open down. And then this value right here is your y-intercept. Okay. The vertex form, h and k, would be your vertex. Just keep in mind that this says subtract h, but so the signs would be opposite from whatever is in your vertex. Again, the a value, if it's positive, it opens up. If it's negative, it opens down. And then this would be the y coordinate of your vertex, right? H and k would be the y coordinate. So this would be your maximum or minimum. So if it opens up, you'll have a low point. If it opens down, you're going to have a high point. So this would be your max. Your axis of symmetry cuts your vertex right in half. So your axis of symmetry is actually your x coordinate. If you wanted to find the y-intercept, you have to let x equal 0 and simplify. All right, and then the last form would be your factored form, x minus r, x minus s. The a value, again, if it's positive, opens up, negative opens down. These are your x-intercepts, okay? They are your roots. Again, the signs are backwards. Okay, so this is all stuff we did before the March break. If I wanted to find my axis of symmetry, I'm going to take my r and my s value. I'm going to find the middle point between them. So I'm going to add them and divide by 2. I'm taking their average. And then that would give me my axis of symmetry, or AOS. And this is your x coordinate of the vertex. If I want to find the y coordinate, I'm going to take this and I'm going to plug it back up into my equation and simplify. That will give me my y value of the vertex. So when you have it, you can take these numbers and plug them back into your vertex form. Okay, and your a value for all of them is the same. Okay, I'm not showing you examples because we've seen this in sections 3.1 all the way up to 3.5. Okay, so we've seen all of those. And then the last kind of slide I have here is for you. It's got the three forms that we looked at. If I have a vertex form and we expand and simplify, we can get to standard form. If I take it and factor it, I can get to factored form. From factored form, I can go all the way back up into vertex form. I find the axis of symmetry, find the maximum or minimum, and I can resubstitute it up here. Don't worry about going from standard form up here. We have to do something called completing the square. We will get to that later on in the course. Okay, so that's a summary. I know there's no examples, but that's just a summary of what we've done previously in chapter 3. So take a quick look at this video and then hopefully you'll start to remember some of the things that we did. Okay, now that you're ready, let's move on and get into chapter 3.